So this is the introduction of the data structure and algorithm. So what we will learn in this slide is what is data structure and what is algorithm and why do we need to consider DSA. So in this case, DSA is data structure and algorithm. And I will give you a brief introduction to Python and how to install it shortly. So you can do the installation by next week. So what is data structure? As I mentioned in the last slide, we will learn some of the data structure. For example, array, list or linked list. There will be several linked lists such as singly linked list, doubly linked list, circular linked list. And you will also learn about stack and you will also learn about queue. So those things are the data structure. So what is this data structure? Because this is the methods of organizing data in your computer. Because when you have data, if you do not organize it well, then it will be too complex to analyze the data. Now, let's see example. In this example, we have a map. The house is here and you can go to the store. If you look at this one, the line has no arrow. So it means you can go to store from house and you can go to house. If you have arrow like this one, it is one way, only one direction. So the store, if you are now in the store, you can go to police office, but you cannot go back to the store. I think if you drive, you know, Il Bandung, so only one direction. So from the service, you can go to the school, and from the school, you can go back to the police office. From the house, you can go to the police office, but you cannot go back from police office to house. From house, you can go to the intersection. From the intersection, you can go to your house. And from the intersection, you can go to school and go to the intersection. Now, the thing is, what is the best way to save the data? One way to save the data is to check between two locations. So this is one method. It means I want to save the data house and store. House and store because I can go from house to store. I can also I can save the data like this one, store house, because I can go from store to house. I can save the data like this one, store police service, because I can go from store to the police service. But there is no data in this service store. Okay? There is no data because we cannot go from police office to store and spawn. Okay, so this is one way to save the data. But there is another way to save the data. We want to check the origin. Origin means you start from house. So from house, what are the destinations? So from the house, you can go to store, you can go to post office, you can go to intersection, and you can go to store, you can go to the post office, and then you can go to intersection. What about from the store? From the store, you can go to the police office and you can go to the house. So you can go to house and you can go to the police office. And so on. So this is one data structure. And this is the second data structure. The question is, which is the best data structure? It is not easy to analyze now because the data is too small. So we will learn during one semester what is the best way to do this kind of problem. So that's the data structure. What about algorithm? So the algorithm means it depends on your data structure. You can do, for example, sorting. You can do, for example, searching. You can do recursion, and you can do dynamic programming, and etc. So this algorithm means that it is the operation on different data structure. So if we use the data structure number one, then the algorithm will be related to the data structure number one. If you use data structure number two, then the algorithm will be related to the data structure number two. So the algorithm will be different based on the data structure. And the most important thing is the analysis. So we need to analyze the algorithm. For example, the estimation of the running time of the algorithm. The running time of the algorithm means how long it will take to finish the analysis. If the analysis takes a long time, then you will not use that algorithm. Because if the performance is bad, how can we perform? For example, if you use Naver for your navigation, if you want to find a trip and when you use a trip, it takes 10 minutes. Then, of course, we will not use that one because it is too long. We want to use the app because it can provide us a fast solution. So there will be an algorithm analysis for this one. So let's get back to this example. With the algorithm example, what does it mean? At first, I want to go from home, from house. Okay. I want to go to school. What is the best way to go to school? Because if I want to go to school, I need to check every possible path. I can go to school from house to store and then go to police office and then go to school. I can go from house to the police office and then go to school. I can go from house, go to the intersection and then go to school. So there are three alternatives. But what is the best way? So we need to find places that you can go from house. From house, I can go to store, I can go to the police office, I can go to the intersection. And then from each of the place, find all paths. It means if I know I can go to store from house, okay, there is a path from house to store. If I can go from store to the police office, then I can have another path. And then I can go here. So this is one path. This is another path. And this is another path. We call it path or route. And then we can have the distance. What is the distance from house to store? What is the distance from store to police office? What is the distance from police office to the school? And then we can check also what is the distance from house to police office? What is the distance from house to intersection? And so on. After we calculate all the distance to the current place, then repeat this process until you reach the school. After you reach the school, then compare the distance. If you get the shortest, then you can use that one for the recommendation. You can use that one for the user. So there will be some step to do the algorithm. So we call this is the algorithm or the operations. So let's get back to the data structure. If you use the data structure number one, how can we proceed with the algorithm before? It means if I want to start from house, okay, so I start from house and then I will check what is the next destination. Okay, from house to start. And then I can check what is the distance. And then start to house. Start to house. Okay, I can check the distance. And then I check start to police office. Because we have start as the destination. So start and go to the police office. We will check another distance. So there will be a distance from house to police office. And so on. So we will check one by one until all things. And then after that, we will check what is the distance from house to school. Means we will check every of those data. How about the second data? In the second data structure, we start from one origin. So house, now it is easy to know the destination. Okay, this is the destination store. We can calculate the distance. From house to police office, we can calculate the distance. From house to intersection, then we can calculate the distance. After we know the distance, so we can check from store. From store, we go to house. Okay, house is the same with the first origin. Then we can skip. House store to the police office. Okay, then we can calculate the distance. From police office, we can go to school. Okay, we can calculate the distance and finish. And so on. So the algorithm will run only based on the origin and then check each of the destination. So because the data is not so big, we can see which one is efficient. Based on the operation, there will be different operation. There will be different step. We will learn this one. Okay. Different data structures require different algorithm to process problem. That's the problem that we can consider during one semester. Now, the question is, why do we need to consider the DSC, data structure and analysis, or the data structure and algorithm? So when the data is big, that's problem. Now, there are many terms like big data. So in the big data, I can just make it short with V. So big data is a collection of data from various sources, many sources, and then usually people will use the 3V. 3V means the volume, variety, and velocity. Over time, other V have been added to description of big data. So this is the additional 3. This is the first 3, and then this is the additional 3. The first 3 is volume. What is volume? Means the amount of data from the myriad sources. So it means from the very huge resources. Now the resources not only computer, but we can use the supercomputer. We can use the data center. So the size of the data is very big. Variety. We use the data not only from computer, we use also smartphone, we use also smart car, we use smart city, we use smart industry, and etc. The velocity means the speed with big data is generated. If you do with the stock, the data will be every maybe 30 seconds or 1 minute. If you use Bitcoin, if you are a trader, Bitcoin, the data will be every second. If you use the automated vehicle, so the data should be real time. So the speed, yeah, sometimes it is every second, or sometimes it can be every minute, sometimes it can be every hour. But if the speed is very small, like every second, then the data will be very huge. The volume will be very high. There's also another 3 concepts. We call it velocity, the degree to which big data can be trusted. So now there are many false data, fake data. Which data can we trust? So we call this is the velocity. Value, whether the value is for the business or not. If the value is for the money, then okay, it is related with economic data, from J data. If the data is only for healthcare, then the data is only for the health in the hospital. The variability, the ways in which the big data can be used and formatted. So now we know the data can be in the text. The data can be in terms of image. The data can be in terms of audio. The data can be in the term of video. So it is variability is high if the data is different. And the text, it can be different. If you use Korean language, the byte will be different with the English, which use the alphabet. And it will be also different with the Chinese character. It will be different with the Arabian text, and so on. So there will be a variability for each of the data. So let's say this is one example about the data in Beijing. When we want to capture the real-time data, there are 67,000 GPS equipped taxi cabs in Beijing. So you can imagine how you can analyze this kind of data. If you don't consider the good data structure, then your analysis will be very slow. If you provide a good data structure, then you can do real-time analysis. And we need to consider the algorithm. When an algorithm is complex, then what happens? Constant means no increment on time. The number of objects. So if I have 100 rows of data, or let's say I have 100 megabytes of data, and I have 100 terabyte data. So the number of object means the higher number of the data. When the data is higher, we want to know what is the time. So this is time. It is good if you can provide constant. So when the data is getting high, the time is the same all the time. Oh, this is very good algorithm. There can be a linear algorithm. The linear algorithm means the operation type increment is linear. When the data is getting high, the algorithm, the time to run the algorithm is increasing in the linear line. Or we have also another complexity, we call it quadratic. The operation time increment is quadratic. It means when the number of objects increase a lot, the time also increase a lot. So this is we do not want because this is too complex. This is what we want because it is very efficient. And how can we make the algorithm with the constant time? That's always the big issue because when the data is big, of course, there may be something like this linear problem. When the data big, then the time is also increased. So we will learn how to analyze the algorithm, how to find the best algorithm, or how to find the most efficient algorithm for our data. Another issue is when you use your computer. What computer do you use? If you use your desktop, maybe the utility is high. But if you use your laptop, maybe the utility is lower than that. If you use tablet, of course, the utility will be lower than desktop and laptop. If you use your smartphone, this is the lowest one. So if you choose the wrong data structure and if you choose the wrong algorithm, maybe it will not run in a smartphone because you run the algorithm only on the desktop. So we need to consider the best data structure for every device. And also, how if we want to run our algorithm in the cloud? Now, many companies, they perform the analysis or they manage the data storage in the cloud. let's say the AWS, AWS, it is from the Amazon Web Service. So in the Amazon Web Service, they have one kind of computer, they call it this M6G XLOG. In order to access the data, so usually we call in the cloud, there will be a service and write. So you can write on the cloud and then you can read the data. And then the cost will be $0.154 per hour. Is it cheap? You think this is very small number, but actually this is not only per hour, but it is also per megabyte. Then if you do not provide a good algorithm, you can see the price will be very high. Azure, Azure? This is from Microsoft. Microsoft Azure. So you can save your data also in the Microsoft Cloud. Its name is Azure. Google Cloud, they also provide the service to save your data and you can read and write your data. And you can see the pricing. Okay, this is the price for the Azure, then this is the price for the Google. Of course, they provide different kind of computer. So you need to check the spec of the computer. Which one is better? Which one is worse? The better computer may be the higher of the price. And it depends how you can save the data. So if we use the cloud, you need to consider the resource efficiency. If you don't consider the resource efficiency, of course, you need to pay a lot of money for just read and write the data. Okay, so that's the thing why we need to learn about the data structure, because in this era, data is very important, and also making a good algorithm is important. I think I will not discuss a lot of things about the Python because many of you already learned Python. So Python is created by someone named Guido van Rozek in 1990 while he was in the Amsterdam. Now he is in the USA, and Python is free, open source, and it is object oriented. Everything is an object. So I will not give you the basic Python in this class. From next week, I will just skip all the small things and I will just teach you the big things. So I cannot do Python in this short time frame. So I cannot teach you again like what is for, if, and then what is something related with function. Yeah. So you need to find by yourself. But I will try to give you a taste of the language. So I will focus on the object oriented because in this class, most of the code that I provide to you will be about the object oriented. So there are many documentations. You can use the tutorials, you can use the libraries. Also, there are many books about Python. So you can refer to the book if you want to learn Python, or if you still want to access the video from my course about computer programming, yeah, you can also use that resources. If you want to check the website for the Python, so you can go to the python.org. This is the official Python website. There are many tutorials and there are many references that you can use. And also you can use resources like the Stack Overflow, GitHub, and etc. in order to enrich your knowledge about Python. So as I mentioned to you, we will use the Jupyter by Monday. Okay, I hope that you already have your Jupyter. So you can download your Jupyter by downloading the Anaconda. By downloading the Anaconda, if you use the Windows user, you can use this one. If you are a Mac user, you can download this one. If you're a Linux user, you can use this one. Note that do not use Korean character for the installation folder. So for example, yeah, you can use like this one, C clone /users /user. Okay, so using the alphabet until now, yeah, there is no solution with the Korean character. If you use your Korean name for the user, it will be this. When you install Anaconda, please use the alphabet ABC. So for example, like this one, you can see here. So later you will add the folder of Anaconda. It means the Anaconda will be saved in this folder or will be installed in this folder. So if you know the folder name, then you need to do something related with the environment variables. So after you do the installation, you need to go to Hwangyongbyunsu. So you can see this one, there is a system Hwangyongbyunsu kanjip. So in the Hwangyongbyunsu, we have the path. And yeah, in this case, I think the administrator already used Python 3.13. So if you see this one, we use this folder for Python. We use this folder for Python. If you use Anaconda, then it will be different. But basically, you need to put in the Hwangyongbyunsu kanjip. So if you have any difficulties, we will discuss it on Monday. Please install it first. If you have any problems, then let me know. I will fix it on Monday. And after you do this Hwangyongbyunsu, so you can add or edit environment variable. If you install it in this folder, then put this one Anaconda 3 /lib, Anaconda 3 /scripts, Anaconda 3 /library in your environment variables or Hwangyongbyunsu. So the files will be like this one. So it is the previous one. I have the scripts. Okay, so you can put this one users Anaconda. Okay. And then yeah, if this one okay, I think everything will be okay. You can run your Python with the Jupyter. So if you install and everything works well, so you can go to the command prompt and type Python. There will be no error if Python installed correctly. So in this computer, if I call the command prompt, or I think we call it myong ryong prompter. Yes. Okay, myong ryong prompter. So if you use this one, if you click Python, then yeah, if everything is okay, then it works like this one. Or if you call the Anaconda prompt, if you run Jupyter Lab, then it will show something. If everything is okay, then you can see this Jupyter Lab in your environment. Anyway, please try to install your laptop, and on Monday, let me know if you have any difficulties. Because on Monday, I will start using this Jupyter Lab, and on Wednesday, I will also use this Jupyter Lab. So I hope there is no problem with your Jupyter Lab. If there is still a problem with your Jupyter Lab, maybe I will use the Google Colab. In the Google Colab, this is a Google Colab. Okay. So in the Google Colab, you can so if you use Google Colab, it means you don't need to install anything in your computer, but you need to have internet. That's why I think it's better for you also to install Jupyter Notebook in your computer so you can work without internet. If you have internet, then you can use the Google Colab like this one. The idea is similar with the uh, Jupyter Notebook. Let's say I have a comment print. So yeah, there will be the result. Hello, this one. So in the Jupyter Lab, yeah, you can also use this notebook, and then you can have the hello. So you will see the result. Okay. Um, okay. I think that's all for today. Any questions, comments?